Hello, everybody, and welcome to my climate stories. I want to start off this week with some good news because quite recently, on 1st of October, this has been in the news on Science Mag. So, this is the article that I will also link in the description, of course. And it says that the European Union will be building a digital twin of the Earth to revolutionize climate forecasts. Very catchy title. We'll see how it will play out because this system is not in operation yet. But it all sounds very promising and interesting, and I will get through this, bit by bit, by quickly touching on what digital twin actually means. The term digital twin comes from the industrial production processes, and so on. So this ranges from product design to individual machines and whole production processes. There is an interesting video from a few years ago by GE, which I will link in the description down below. It's quite marketing heavy and a lot of catchphrases get thrown around, but the basic idea is that you basically simulate the whole system that you want to simulate. So either a airplane engine, as you can see here in the image, quite a complex piece of machinery, and when you simulate every component of that machine and also the wear and tear that this machine experiences through its life of service, then you can basically predict when you will have to change the oil, when you will have to replace certain components. And this is the key idea behind this whole digital twin thing, to reduce service as much as possible and to only service the machine when it's necessary, and to also predict certain aspects of production, for example. So when the production cannot handle the demand anymore, when you have to buy new machines or optimize your processes, for example, all this can, in theory, be predicted by a digital twin. And so the EU consortium took this basic idea of the digital twin from the industry and transported it into climate science. And they now call it destination Earth, or destinE, which is basically a complex climate model that is simulating the whole Earth. So now you might think, well, that's not really new. We have had climate models for 50 or 60 years now. What's actually the great news about this? Well, it's actually two things. The first thing is about the model itself, because they will reduce the so-called grid spacing of the climate models that they will run to 1 kilometer. And current complex climate models that model not only the Earth's surface or the ocean surface temperature, but also the dynamics within the atmosphere. So those are three-dimensional models that simulate the climate over the whole globe and all of the atmosphere. They have usually a grid spacing between 50 to 100 kilometers, because it takes quite a lot of computing power to simulate all of this. And now this EU project will reduce that grid spacing to 1 kilometer, which is really amazing news. And they will use 3 supercomputers that are situated in Sweden, Italy, and Spain, I believe. The second big plus point of this project will be that the models, the climate models that are running on these supercomputers, will be able to make real-time predictions. And to put this into perspective, I thought I'd dig out a little example, which is the eruption of Mount Pinatubo in the 90s. So back then we of course had climate models already, but those were because we didn't know that this volcano will erupt when it did. They couldn't predict the eruption, but we were able to train those models to the effects that that eruption had on the global climate. So this is an example from a paper that was published where they calibrated the model to account for or to calculate for the effects that the eruption of Mount Pinatubo had in 1991. And that trained model that's shown in that blue line here follows quite nicely the measurements that were actually taken all around the globe. A model that did not take those findings into account is shown in the red curve. So what does this have to do with Destination Earth, the digital twin climate model? Well, with this grid of 3 supercomputers, we will be able to make those kinds of simulations that were done in the 90s over several years, to do those in real time now. So if a volcano were to erupt within the next few years, we will be able to predict the effect that that eruption has on our climate in real time with that destination system. And one of the goals that is actually stated on the EU website is that policymakers all around the globe actively use the data on that system and the results that that system gives. So, for example, a country leader in a country that is close to said volcanic eruption can use that data to actually make correct decisions and help their population cope with problems due to that eruption better. So yeah, this is really interesting news. I think this is a great news to establish the European continent and the European Union as a space for doing cutting edge science. I think it will be good to bring the EU as a whole more together, and it will also be of great use scientifically because, as I said, all the data will be open source. It can be used worldwide and in real time. Of course, they will also do long-term predictions, longer-term predictions than they already did. But I think this real-time digital twin thing for the Earth climate is, it's amazing news. I'll keep this on my radar. I will keep you posted when there are any news on that subject. If you like that sort of video, please click the like button. Please consider to subscribe. If you have any questions or comments, please leave those down below in the comment section. I would love to hear from you. Until then, I wish you a great week. Take care and see you soon.